had the cruise ship challenge, we were trying to think, what really hasn't changed, and that's the shore excursions. So once you've booked your cruise and you log onto the website to look at the excursions that are available, you're going to see the same exact excursions that I see, that my grandmother would see, that a family with kids would see. They're all just going to see these same ones at the top. And that might not be the best fit for them. Everybody has a lot of different needs, and there's lots of different options out there. So we figured out we would try to help people and be able to actually recommend personalized excursions just for them, tailored to what would fit them best. Now, obviously, that's a very big problem, one that humans might have a hard time solving. So we figured we would be able to do that using machine learning. So this is the front page of it right here. So kind of a few things. We figured a lot of people, especially some of the older clientele that is going to be booking cruises and booking the excursions, are going to be doing it on their desktop computer rather than on their mobile. It is fully responsive though, so you are able to scale it down and still use it on a mobile phone. But we figured just for the time constraints, it was best just to focus on the desktop app, since that's where a lot of people will be doing their booking. So right now, you'd log in through Facebook. There is also an option that would be added later on to actually log in using the cruise number as well, but for sake of simplicity, it just works through Facebook for now. So when you click on the button, we'll go into the magic a little bit later, but the magic is happening right now, and it returns back a list of customized excursions.
Okay, so this is the stack that we used. That front-end web app that you're looking at was served up by Netlify. It's a lightweight React spa. We use modern HTML and CSS on the front end. When you click that Let's Go button, it's reaching back into a C# built .NET recommendation engine, which is in ASP.NET in Azure. And split into kind of two layers. We've got the API layer, and then we've got a core set of classes that handles all the machine learning kind of model preparation stuff. That's because it's used in a couple different places. So your prediction kind of goes in there. And then just broadly speaking, we'll get into how this works later. It goes out to a model that's in Amazon machine learning and hits the model and gets the results back, comes back to our API. API kind of looks at the available excursions, looks at the prediction data, cleans them up, merges them together, and then returns it back to the spot. And then you'll notice there are kind of two front-end sites here. The other was a data collection site, which we'll get into a little bit more later. That was built by Alex. That is a Rails app that sits on top of Postgres database, and we use that to collect a lot of the data that was used to train the model.
When we were first thinking about how to create this, like we said, we were looking more at desktop, and we were talking about your target demographic there. Thought desktop is probably our best use for this, and for sake of time, we went strictly desktop when we were working on our mock-ups with this. So we tried to keep it pretty simple and straightforward to where you go there, you know exactly what you're doing, you're logging in with your Facebook, and it just goes straight forward. Everything's very, very simple and minimalistic here. So we did incorporate a lot of modern HTML and CSS to do these types of things. Font Awesome was a big piece for us, being able to get these icons in there pretty quickly, so we didn't have to worry about designing those, and also using Google Fonts to pull in some nice minimal fonts, but using some font weight to add a little variation there.
So just broadly, a user visits a website like you saw in the demo. They press the Let's Go button. They authenticate with Facebook. They hit a loading page where we didn't really have our loading indicator working, so I hadn't really time to fix that. And then they see the results page. So what happens between Facebook authentication and the results? Well, from Facebook, we get their email address, profile photo, and we get their gender. We take that, those 3 data points, and we feed it. It's actually marshaled by the React Spa into the API. So we grab the information, toss it into the API, and then out come the recommended excursions, and then those go back up into the results page. So how does that work? Here's the general architecture of what we were able to build in that short period of time. So starting from that kind of where it was left off before, this was a high-level overview. Here's kind of like a lower-level overview. We take our profile photo, and the first thing we do is we shove it in the Google Computer Vision API, and that returns a list of topics. So you put in a photo of yourself standing there with a hockey stick, for example, it's going to return like hockey, for example, or hockey stick. the next thing that happens is we've got a bunch of topics in there. We kind of clean out the topic text and we prepare it and hold it. Then we take their email address and we feed it into the Full Contact API. Full Contact has a service that allows you to feed in an email address and it goes and gets all the social media profiles that exist for you. So for example, Twitter, Facebook, they've got a whole laundry list of them on the website. Those have many times publicly available bios. So you have blocks of text basically that you've typed in at some point in time that are then publicly available on those websites. It goes and pulls that data and it then kind of pre-processes it to get it ready to go into natural language understanding API. This is run by IBM. We combine all that text, put it into the natural language understanding API, and out of that comes a list of categories. So why do we care about categories instead of just broad text or topics? It's because the topics, there could be, I don't know how many of them there are because it came from Google's project where they were basically defining a set of topics, but if I were to take a guess, it'd be hundreds of thousands, maybe even like 1 million potential topics. You can't train a machine learning model very easily off of that, so we need to pare that down into a list of features that you can train on. The IBM Natural Language Understanding API takes its broad list of potential text, reduces it down into a list of much more manageable list of categories. I think we're talking about hundreds in here. So out of these categories, we then do some category processing and we determine a set of markers. Now we have for this project, we created 4 separate models, one on activity level, one on preferred category, one on preferred price, and one on duration, right? And so for each of those models, we came up with category marker mapping. So what that means is you might have a category for sports and recreation, and then what did we map that to? And
that would be, like duration.
For duration, for example. So instead of looking for the presence or absence of all of these hundreds of categories, we instead pared it down to what we thought were kind of well-suited independent variables for the model and ones that would be relevant. So why did we do that paring down process? It's partially experimental to see if it would work well in the model, because a lot of this is kind of like empirical process of just trying things and seeing what works. But another part of it was also there's, forget the name of the law, but the more dimensions or features you have, the less predictive your algorithm is with the same training data set. So we pared this down to about 20 for our training set that we had. So these get mapped through that mapping process. Mandy did that process herself. Those go into the model input generation and basically take all this data, and we have a whole set of C# functions and classes that translate it into something that we can feed into the machine learning model. And then we feed it into the machine learning model. As you can see here, activity level, category, price, range, duration. The actual model that we ended up using was multinomial logistic regression, which is hosted in Amazon. You could also feed it into a deep neural net with a number of output nodes instead. Just for sake of getting this working and something you can plug into production and scale up, we chose to use Amazon machine learning. We then take the output of that, which is some basically like the probability of a match for each one of those categories based on the input data, and we do some additional processing in that C# code, and then we merge that into the recommended excursions. So all the excursion data that we have is tagged with those different dimensions, and we can take all those dimensions together and their probabilities and determine which of the best excursions match those, because we already have that structured data for the excursions. Then we take those recommended excursions, and now we just expose that over the API as a response in some JSON that then goes back up into the React app.
When you design something like this, you have to train the data somehow, right? Like you can't just say, "Dear Magic Box, give me recommendations." So we came up with, what can we build super quick? Well, before we can build anything and get recommendations, we need to know what excursions exist. So the first problem we had to solve was, how can we get a whole bunch of excursions into a database super quick? luckily, I had been toying around with web scraping in Ruby for a while prior to this, so I built a horribly quickly coded web scraper to basically attack Carnival's website and scrape 1,400 plus excursions off their website. And the code for that is awful. It looks hideous. It will die with me, but it did its job. It used Chrome's headless web browser that just came out a few months ago to go out and literally just constantly cycle through each excursion page, yank some nodes off the DOM, give me the text and some of the things we need, the duration, the category, all of that stuff. We then opened up a quick survey site off of that database to basically say, hey, if you were to take a cruise tomorrow, what duration, log in with Facebook so we can grab your profile picture, your gender, your picture, and then tell us if you were to take a cruise tomorrow, what type of excursion would you be interested in? And so we did that just on a quick Rails app using Heroku and Postgres, and then we threw it in front of Amazon and Turk, and we basically just said, we'll pay you 30 cents for your opinion or 50 cents for your opinion on this. Give us as much information as we could. We took that data, and that's what we used to actually train up the machine learning. Because again, we didn't have any data. Like if we had real life cruise data, if we had passed, the last 10,000 or 100,000 cruisers and what excursions they bought and what they had, then the model would be, so much smarter than it was. But we wanted to prototype this, so that was the quickest way to zero that.
Well, it seemed like if your software is running on a cruise ship, you might not have access to the outside world. That means you own that networking structure and you control the ways that the users get access to your application. I think that's a massive concern.
I think it's just a really great place for machine learning because you have really this whole rich data-filled ship. I mean, because you have your room key card, so you can track everything. You can track which restaurants they go to, which drinks they purchase, if they go to the spa, all of these different parts around the ship, you can track them, and you can use that to make their experience a lot better.
Absolutely.
Yes.
And not just because we won.